we move ahead to the next module of stationary waves, and in this very module we are going to learn the numericals on the equation of stationary wave. Yes students, we studied the equation of stationary wave, which was y is equal to 2a cos 2 pi x by lambda multiplied by sine 2 pi nt. So on the basis of that equation, we are going to study the numericals. The very first question comes like this. The equation of two waves along a string is given by y is equal to 4 sine 6 pi t minus pi t by 8. And the second equation, y is equal to 4 sine 6 pi t plus pi t by 8. Where x and y are in centimeter and time is in second. What is asked in the question? The very first sub-question. It is that will they form the equation of a stationary wave or will they form a stationary wave? The second question is something like this. What must be the distance between the two nodes in case they form a stationary wave? The third question is, what is the resultant amplitude? At a point x is equal to 12 centimeter, is it a node, an antinode or any other ordinary point? So students, in this question we are being provided by the two equations of stationary wave, and these are the following questions that is asked. Now how to move ahead about this problem? Let us go ahead to find out the solution by writing the equations of two wave. I know the first wave is given something like this, that is y1 is equal to 4 sine 6 pi t minus pi x by 8. Also, we can write the same equation as 4 sine 2 pi, because we have taken 2 pi as common and inside it is 3t minus x upon 16. Now I can compare this equation with the standard form of equation of a progressive wave. Now this equation is given by y is equal to a1 sine 2 pi in bracket n1t minus x by lambda 1. On comparing, what do we get? I can compare and see that a1 is 4. So I can write that a1 is equal to 4. That means amplitude of the wave is 4. n1 comes out to be 3. That is, n1 is the first frequency of the progressive wave, which comes out to be 3 Hz. In the similar way, the wavelength comes out to be 16 centimeter. Moving ahead to the second equation, we write the second equation as y2 is equal to 4 sine 6 pi t plus pi x by 8, and we can write this equation something like this as 4 sine 2 pi, where we have taken 2 pi as common, and in bracket 3t plus x by 16. Now everything in the equation is same except for in the above equation it is minus sign, in the below one it is positive. So when I compare, I can see that the second amplitude A2 comes out to be 4 centimeter, the second frequency again comes out to be 3 Hz, and lambda 2, that is the second wavelength, comes out to be 16 centimeter. So we have written down the given data. Now when we see the given data, I know that in both the equation we have the same amplitude, same frequency and same wavelength. So I can say that A1 is equal to A2, N1 is equal to N2 and lambda 1 is equal to lambda 2. That means these are the two similar waves, progressive waves, just the middle sign is different. That indicates that they both are traveling in the opposite direction. Since they both are traveling in the opposite direction, it means that they will result in the formation of a stationary wave. So students, the answer to your first question is that yes, they will result in a stationary wave. Moving ahead, the next question was, what must be the distance between the two nodes? Now we know that distance between two nodes as well as two antinode will be given by lambda by 2. Now it can be the same because both have the same wavelength, so it can be written as either lambda 1 by 2 or lambda 2 by 2. And when I solve it, I get the answer as 16 by 2, that is 8 centimeter is the distance between the two nodes. Moving ahead to the next question, what will be the resultant amplitude at x is equal to 12 centimeter? Students, we know the formula for resultant amplitude. It is given by r is equal to 2a cos 2 pi x by lambda. And in this case, we know x, we know lambda, we know 2a. So we substitute all the values in the resultant equation. And after substituting the values, we get the following equation as 2 into 4 cos of 2 pi multiplied by 12 by 16 On further solving, we get this as 8 multiplied by cos 3 pi by 2. The answer to cos 3 pi by 2, as we all know, is 0. So 8 multiplied by 0 will come out to be 0. That means the resultant amplitude is 0, and hence there is a formation of node at x is equal to 12 centimeter. So students, with the help of this problem, we learned how to solve the problems on the equation of stationary wave.